Green chemistry, also known as sustainable chemistry or environmentally benign chemistry, is a field of chemistry that focuses on the design, synthesis, and application of chemical products and processes that minimize environmental impact, reduce toxicity, conserve resources, and promote sustainability throughout the product lifecycle. Here's how to develop sustainable products using green chemistry principles. Atom economy and efficiency. Design chemical reactions and processes with high atom economy and efficiency to minimize waste generation and maximize the utilization of raw materials. Aim to maximize the conversion of starting materials into desired products while minimizing the formation of unwanted byproducts or side reactions. Use renewable feedstocks. Utilize renewable feedstocks, bio-based materials, and sustainable resources as starting materials in chemical synthesis and manufacturing processes. Replace fossil fuels, petrochemicals, and non-renewable resources with renewable alternatives derived from biomass, agricultural waste, or other sustainable sources. Reduce hazardous substances. Avoid or minimize the use of hazardous substances, toxic chemicals, and environmentally harmful materials in product formulations. Design products with reduced toxicity, lower environmental persistence, and reduced potential for harm to human health and the environment. Design for degradability. Design products and materials with improved biodegradability, recyclability, and environmental fate to facilitate end-of-life disposal, recycling, or composting. Consider the environmental fate and impact of products throughout their life cycle, from production and use to disposal and end-of-life management. Energy efficiency. Optimize energy efficiency and minimize energy consumption in chemical processes and manufacturing operations. Implement energy-efficient technologies, process intensification techniques, and alternative energy sources such as solar, wind, or biomass energy to reduce greenhouse gas emissions and environmental footprint. Catalysis and green solvents. Utilize catalysis and green solvent systems to enhance reaction efficiency, selectivity, and yield while reducing energy consumption and environmental impact. Choose catalytic processes over stoichiometric reactions and prefer benign solvents such as water, supercritical carbon dioxide, or ionic liquids. Biocatalysis and enzyme engineering. Harness the power of biocatalysis and enzyme engineering to catalyze chemical reactions under mild conditions, at ambient temperatures and pressures, and with high specificity and selectivity. Explore the use of enzymes, microorganisms, and biocatalytic processes to produce sustainable chemicals, pharmaceuticals, and materials. Life cycle assessment, LCA. Conduct life cycle assessments, LCAs, to evaluate the environmental impacts of products, processes, and materials over their entire life cycle, from raw material extraction and production to use, disposal, and end-of-life management. Use LCA data to identify hotspots, optimize resource use, and minimize environmental burdens. Green product design. Integrate green chemistry principles into product design and formulation to create products with improved environmental performance, reduced environmental footprint, and enhanced sustainability credentials. Consider factors such as material selection, product durability, recyclability, energy efficiency, and end-of-life management in product design decisions. Regulatory compliance and green standards. Ensure compliance with regulatory requirements, environmental regulations, and green chemistry standards when developing sustainable products. Adhere to green chemistry principles, eco-labeling schemes, green certification programs, and voluntary initiatives such as the Green Chemistry Commitment or the Principles of Green Chemistry. By incorporating green chemistry principles into product development processes and adopting sustainable manufacturing practices, companies and researchers can create products that are safer, more environmentally friendly, and contribute to a more sustainable and circular economy.